Hello and welcome everyone to May I AI. I'm Alexander Vachevaik. Currently I have a bachelor's degree in management.
My name is Mustafa Al-Hayani and I just finished my master's in informatics.
And we're both part of TOM AI, a student initiative that is aiming to make AI accessible to everyone. So in our last pilot episode, we talked about ethics and bias in large language models. What other major problem is there in large language models outside of that, Mustafa?
Well, one of the biggest problems currently is the problem of hallucinations when it comes to LLMs.
What are hallucinations?
Well, hallucinations are what happens when your LLM produces an output that is either wrong or, let's say, is not real, so it does not really exist.
Do we differentiate between different types of hallucinations?
So there are two main types divided by research: the extrinsic hallucinations caused by extrinsic properties, so not the model itself, and then of course intrinsic hallucinations that are caused by the model in itself.
So can you give me an example of an extrinsic hallucination? Like how do they happen?
So the extrinsic properties of the extrinsic hallucinations of LLMs are basically, like I said, caused by outside properties, and this is basically the human prompt. So if a human asks something like explains RLHF for LLMs, the model then will see the context of explain RLHF and then says RLHF stands for rights, limitation, harms, and freedom. And then because we said for LLMs, the model will continue with the context saying that it is a framework for models like large language models. Now, of course, the answer is not terribly wrong because the abbreviation is correct, but it's not made for LLMs.
So to wrap up the extrinsic hallucinations, they basically stem from my input into the model. They come from what I give it and from the lack of context or the wrong context. Is that correct?
Yeah, that is correct. So the prompt is basically the main focus here.
Okay, so we've talked about extrinsic. What are intrinsic hallucinations?
Now,
how do they happen? What are they?
Intrinsic hallucinations are basically the faults of the model itself, and they happen due to the notion of what LLMs are. So as you know, large language models and language models in general are made as generative models that are completionist models. They look at a context and they try to generate something new. And this is what happens when the model looks at a certain context and decides, this is what I'm adding now, and forgets about the context.
Can you give me an example of an intrinsic? Like, how does that work?
So let's say, for example, that your prompt is you have Bob's wife is Amy, Bob's daughter is Cindy, and then you ask, who is Cindy to Amy? And then if you do any logical inference, you would realize that Cindy is just Amy's daughter. But of course, when you give that problem to an LLM, a problem might be that the model now decides Cindy is Amy's daughter is not a complete sentence, and then it adds in law. And this causes the hallucination where the answer is now wrong because the model decided to add more information.
So the model is not capable of deducting that kind of logic. It's not capable of inferring the right term from the
situation. So large language models are internally completionist models, which means they do very well on like language understanding and completion summarization, but they're really bad when it comes to inference. Actually, in a benchmark done very recently, they realized that all of the large language models that are known today, when they face a benchmark when it comes to inference by graduate students, they are more likely in the 45% accurate, meaning that they are wrong 55% of the times, which shows just like how LLMs in general are not inference models, right?
Just as a little side note, would that also be the reason why, for example, there's so many plugins into ChatGPT? So they have the code interpreter, they have some sort of math plugin. Is that the reason why they add those?
Yeah, exactly. So for example, if you think about the math plugin, LLMs in general are very bad when it comes to calculating because they do not calculate. So adding a math plugin that kind of finds if the answer or if the solution GPT is trying to give is a mathematical problem, takes it away from LLM to calculate it somewhere and then bring it back, that would be the reason why.
All right, I think I'm starting to understand what extrinsic and intrinsic hallucinations are. But how do we measure like a hallucination? How can we tell if a model is hallucinating or not?
Well, it's pretty tough to do that automatically. Let's say, for example, as a problem I have that I'm trying to get GPT to cite some references for me. So I give it the research I'm working on and I ask it for references. And GPT will generate a bunch of reference lists with the title of the paper, the publications, the authors, and the date. However, if you look at them, the paper was never real, the authors probably do not exist, and it's just a combination of different other papers. Now, if I look at that syntactically, it's a correct answer. But in reality, these papers do not exist. Now, exactly for this problem, it's easy for me to do a Google search, but it becomes hard to automatically detect if it's a real one. Now, for more complex problems, it might be very hard to decide if the answer is just a hallucination.
So we basically have to fact check everything by hand. There's no way to check the truth in an automated way.
Yeah, that is correct.
So that makes debugging and testing really hard, right?
Yes.
All right. Speaking about debugging and testing, quite often I've heard this example that the reason why ChatGPT and other language models, why they hallucinate so much, is that they're trained on the internet. And we all know that the internet contains a lot of false misinformation. So a lot of the times people suggest that if we train a language model on literature and text that we know is definitely true, so something like scientific literature, that would kind of help alleviate the hallucinations, that would make it better. What is your take on this? What do you think?
So
would that help?
Let's start by saying that GPT or all large language models that are big and known today, they have already been trained on most of the literature data that exists, right? But the bigger problem is that there are more, let's say, non-factual information on the internet than these ones. So the question is, do we train more on scientific data belonging to my context, right? Now, let's say there's one of two approaches we can take here. We can decide to get a model like GPT, train it on new data, where we feed it new information, and then hope that now it's more fact-checked. But the problem becomes is that because you're training on, let's say, 10% of the internet when the model's already been trained on 90% or even more, the problem becomes that the model will not forget what it already learned, which means that it will still have this issue inherently. Or the model will just completely forget about the other 90% and only remembers the 10, which might also happen in a bigger case if you get a new model that was not trained before and train it on this data as well, like only this data. Now, what is the problem when that happens, right? You kind of lose the ability of having a fully general model that is able to talk like human, because this is the whole reason why we put that much data into it. And then you get a model that only knows the literature, but is unable to generalize it in the whole forms that you want GPT to do.
But just for the sake of argument, if we had such a model that was really only trained on scientific literature, would that still produce hallucinations?
Well, yes. Actually, these models existed way long ago. There was the whole notion of creating whether music from other musical artists or poems by some poet, or just a book by Shakespeare. And these already existed. And the whole notion behind them was still that we needed the model to produce the work done to a similar person or the individual, but still kind of unique. Mm-hmm. And the whole idea of that uniqueness is what causes the model to be hallucinating.
So in general, there's some kind of trade-off between how generalizable a model is and how many kind of problems you can throw at it versus how correct and specific it is.
Yes, that is true. Correctly? Because let's say a model that does not hallucinate at all is a model just copies what it knows. Mm-hmm. So a model with no capability to hallucinate is a model that just gives you exactly what it read, which is not really what you're looking for.
So in order to be creative, the model has to hallucinate.
Yeah.
So if it doesn't hallucinate, it's not creative.
Yes, it's a more complex, I would say, because creativity is a bit more bigger than just saying the wrong word, let's say. But yes, in general, if you want the model to be its own self, let's say, then you want it to hallucinate some information.
Okay, so thanks a lot for explaining this example to me. I have another example here that I've heard about, and I've heard about these so-called retrieval systems. So can you explain what a retrieval system is and what does that help with hallucinations?
So in layman terms, retrieval systems is where I ask a question, this is my prompt, and I do some work to get the most relevant information that is syntactically and similar to my question, and then I feed that into the model as a context. And then the model is able to read this information as a prompt and then give more output out of it.
So Do retrieval systems work well? Do they alleviate hallucinations?
Well, yes, in most cases we see that models do a lot better. And this is due to, like we said, with extrinsic properties, extrinsic hallucinations, the model is more wrong due to the context of the input. And this adds a lot more context that is concrete and factual, which makes the hallucination slightly less and the information out of it a bit better.
So when I go onto the Bing chat and I asked the ChatGPT instance there a question, is that what it does? Is that a retrieval system in action?
Yeah,
because
so
it also looks up the website and then it copies the website's content and it just tries to summarize using that. Is that how it is?
Yeah, so the way it works is that it puts your question into a search engine, gets the first, let's say, 2 or 3 search results, scrapes them, does some vectorization step to get the whole similarity search that we talked about, and then this is what's given into your model as a context.
You just mentioned vectorization. Can you explain that a little bit further?
Yeah, of course. So vectorization started with this notion very first when NLP started, natural language processing. And the whole idea of it is we wanted to talk about text, but machines do not really understand text. They understand numbers. So we wanted to get every word in the corpus, in our dictionary, to be a number. But of course, numbers are hard because if you give every word a number, you're going to end up with really large numbers. And we still wanted to have an idea, a notion of words being connected together somehow. So for example, if I ask you, what is the output of doing king minus man plus woman?
No idea.
You will get a queen. Because a king that is not a man, but is a woman, is a queen, just through language. And this is the whole notion of what vectorization is. It tries to get this large vector, a list of numbers, where if I can connect them somehow into multidimensional space, they will be interconnected with these syntactically.
So vectorization is if I assign a point in some sort of n-dimensional space to each word, and I try to measure the distance between these points.
That is correct.
Is that how I could imagine? Thank you. All right, then let's wrap it up. What did we talk about today? What did we learn?
So we talked about the hallucination problems when it comes to LLMs. We divided it into extrinsic and intrinsic, talked about each one individually. And then we talked about whether training in any way can alleviate these problems. We also focused on generative retrieval and tried to talk about if this is alleviating hallucination and makes it any better. We also touched slightly on logical inference and creativity, which are topics that are pretty interesting. And yeah, I'm looking forward to what we talk to next.
Yeah, thank you. Thank you for listening to May I AI, and see you in the next episode.